Hello, I'm Dan Olds, and welcome to another edition of the OrionX Download. As joined here again by Shahin Khan and Steve Perrenod. How are you guys doing?
Hey Dan, how are you?
Hi Dan, great to be back.
How are things in Thailand today, Steve?
Unbelievable thunderstorms. I hope it doesn't
Oh.
interrupt our conversation.
Well, it's going to be a dramatic conversation anyway. Maybe we could use the thunder and at least the sound of the lightning as a dramatic backdrop to the conclusion of our exploration into bitcoins, cryptocurrency, and blockchain. And if you've been along with us for the ride so far, we've had two episodes prior to this. The first episode was really looking at Bitcoin and blockchain's beginnings by examining Bitcoin, a peer-to-peer electronic cash system, which is the Satoshi Nakamoto paper that launched the whole thing. We went into that in quite a bit of detail. And then in episode 2, we started the journey of a transaction going through blockchain. And in today's episode, we're going to wrap that up and discuss the rest of the journey of a transaction, but also take a look at some other considerations with blockchain and Bitcoin. So
I think we're going to specifically discuss why you can or cannot separate them from each other.
Yes. That's right. So, who wants to start us off?
Maybe one thing we can do is to look at what a transaction is comprised of, what is the format of a transaction, and then we can kind of take it through the rest of the journey. Sound
Sure.
okay?
That works.
Okay, so a Bitcoin transaction as a piece of text includes scripts. So it has some data fields, and it also includes some scripts, and those scripts give you a lot of programming capability, so you can add conditions, you can make them a little bit more complicated, etc. There is an input section to it and an output section to it. The input basically redeems the coins that are to be sent, and it does that by referencing previous transactions. So there includes the hash of a previous transaction so that you can prove that you actually own it and you are entitled to send it to someone. It includes the sender's public key, and that can be matched with the previous transaction. And it includes the sender's signature of previous transactions, so we can be sure that it was the right person sending it. The output portion assigns the coins that are to be sent. So it includes the amount of bitcoins that are to be sent. These are done in the unit of Satoshi, and a Satoshi unit is 100 millionth of a bitcoin. So one bitcoin is 100 million Satoshis.
That's a lot. That's very granular.
But it is designed so that as the value of Bitcoin varies, you can go to enough significant digits and be pretty accurate. So it includes the amount to be sent. Those could be multiple records. And then whatever you didn't spend is like the change that is assigned back to the receiver. And then there's a small transaction fee that is assigned to the miner that is going to validate and book the transaction. And it includes the hash of the receiver's public key. So this hash of receiver's public key is what the receiver can use in a future transaction to reference the transaction that sent the coins to them to begin with.
That's the proof of it.
That's the destination, and then because it is a hash, the destination can be used as proof of the new sender. So if you think about it, there's a transaction A, for example, and that transaction A can reference two previous transactions, and those can be input to that transaction. Let's say an older transaction gave you 20 bitcoins and another one gave you 30 bitcoins, and you can reference those, and you can reference the hash of your public key and prove that it is you, and then you can kind of assign it to someone, add them all up, 50 bitcoins. Let's not worry about the change and the transaction fee for now. So now somebody else is eligible to redeem that from you in that transaction. Now, in a future transaction, the person who's entitled to redeem it can reference this transaction that you combined 20 plus 30 and made it 50, and they can now distribute it, let's say, to two different outputs, 10 bitcoins and 40. So as such, these transactions keep referencing each other, and you keep track of who's entitled to how many bitcoins.
And it's a chain of proof.
Mm-hmm.
And a record of record. I mean, it is the record.
Correct.
The journey of every Bitcoin. Okay.
It is the one single true ledger, but it is distributed, and anyone can have access to that ledger, and it resides in many places. Really, multiple copies of it exist in many places.
Many multiple copies, I would imagine.
Yes.
Okay. Well, let's move on and talk a little bit about the formation of a block, and we just talked about some of the transaction validation.
Yeah, Dr. Steve, you want to take us through
Sure.
what happens to the transaction now?
So Shahin has just nicely described, the input and output side for transactions. And now what has to happen is what's called a mining process, where these transactions get chunked up into blocks. And currently a block will hold roughly 2,000 transactions in the Bitcoin world.
Okay.
And miners are racing to be the one miner or mining pool, as it were, that successfully processes that block. And so what they're doing is they're both validating all the transactions, and Shahin has already gone through the sort of early stage of the validation process, but then it's got to be committed into the block. And the miners are incented to do that by transaction fees, but more importantly, they're incented by getting a block reward. And currently, about 90% of their revenue comes from the block reward, and about 10% comes from the transaction fees that were mentioned earlier. And that reward, it changes over time, and it's built into the Nakamoto consensus protocols as to how it changes. In the past, it had been 50 bitcoins and then cut in half to 25 bitcoins per block, and it's currently a reward of 12.5 bitcoins for being the successful miner to commit the block.
Okay.
So the transactions go out to the whole network. The miners look for a bunch of transactions and pool them together enough to have a block. And they're obviously going to pick the ones that have the best transaction fees associated. So those will get processed the most quickly. But when they've got a block's worth, then they rush to solve the cryptographic hash problem that's associated for that block.
So this is the so-called proof of work.
This is exactly that. It is what's called proof of work. The proof of work is being the one that solves that problem first amongst all the miners. And that mining process takes a hash of the prior block. It combines that with the thousands of transactions that are going to be committed in the current block. And there's another little thing which is called the nonce. And the
What's
nonce is a
Nonce.
guess.
So nonce is
guess.
Nonce. What does that word mean?
A nonce is like just a little thing.
Yeah.
It's if you're cooking, you say, okay, add a nonce of salt.
Oh, I see.
I
So
have
in
never
this
heard that in
case-
my entire life, Steve.
A smidgen.
A smidgen.
Yeah, you've led a protected life. We all know that.
I've not heard of a nonce as a term, but okay, I'll go with it.
Anyway, it's just this little guess, and it's sort of like you have a lottery ticket. So each miner will guess at a number, and that number is like a seed or a kernel that's part of the total cryptographic hash problem that has to be solved. And what they're trying to do is take the hash of the thousands of transactions that are eligible to be committed in the current block together with the hash that was already determined for the n-1 block, the previous block, and then hash also this little guess or nonce. When they hash all those things together, the problem that they have to solve is that the resulting hash of that entire mix has to be less than something called the target. And the target can also sometimes be referred to as the difficulty. And actually the difficulty and the target are sort of the inverse of each other. As the difficulty is higher, the target is smaller. So what they're requiring is that when they hash all those things that we just mentioned together, that the resulting hash has a bunch of zeros in front of it, binary zeros, as it were, a long string of those. So the resulting hash has to be less than the target that's currently the determined target. And if they're the first ones to do that, then they commit the transactions, they broadcast out to the network, yeah, bingo, I've got it. And then they ask for the reward. And other miners will validate their blocks just to make sure they're not cheating, and that the other miners want to know that that block was indeed good and that they should give up on the current block and go ahead and start working on a subsequent block. That difficulty gets adjusted automatically within the protocol in such a way as to keep a block commit time, basically solution time for this hash, and the number of transactions within the block, to keep that all within about a 10-minute window.
Now, what is the incentive for miners to work on the same block more or less, or indeed when somebody says I won, for them to accept it and send it all around?
Well, the incentive to work on the block, of course, is receiving the reward. And, if you're going to be in this race, it's sort of like being in the Kentucky Derby or the Preakness. You better have a pretty good horse. You better have a pretty good mining gear or mining pool with specialized ASICs and so forth, so that you know that you have a chance of winning the race. And that's the incentive, that the economics of your mining setup in terms of your capital costs and your electricity operating costs are such that the reward is worth it. And then you don't want to keep working on something if essentially the race is already finished. You don't keep running, but you check to make sure. You look back, okay, or you look ahead. Did he cross the finish line? And you validate that.
The other thing is that because this is basically a trial and error, your chances of winning on this block are no different than the chance of winning on the next block. So it's not like simply because you've been working on this block for like an hour, you're almost there. You may still never get there. So you might as well switch to the next block and declare the first one done and move on.
Well, in fact, what you do is you try this nonce and it doesn't work, and then you try another nonce and that doesn't work. So you end up trying many, many nonces. So it's like you went to your convenience store and you bought a large number of lottery tickets.
Right.
And you start scratching them.
You're scratching them off in order.
Except that scratching it takes a lot of computing power.
Yes.
Now, I wrote all of this down as a stepwise thing, so I'd like to take you all through that.
Okay.
So the way I understand is that any node in the network can choose to participate as a miner. Miners validate transactions and then commit the transaction blocks, and they do that for a chance to receive Bitcoin rewards and transaction fees. Right now, transaction fees are modest, really are there to avoid spam, and really are there potentially to prioritize your transaction. But the Bitcoins that are generated with each block are the main thing. As Steve mentioned, you get 12.5 Bitcoins at about $4,500 per Bitcoin right now. That's substantial sum. When a transaction is formed, it is sent to the whole network. Now, everybody gets it, but those who have elected to be miners actually will pay attention to them. And you can become a miner today and stop tomorrow and then come back again the next day. It is checked for eligibility according to several parameters, like 20 to 30 parameters. The miners select from among available transactions to add to the block that they are building. and they relay that to the network, and that will increase the odds that the block they're working on is the likely successor to the last committed block. Which also means that there are lots and lots of blocks in the system that have different permutations of transactions in them because of the transactions that each miner selects to add to the block. And low-fee transactions may have to wait or be resubmitted with higher fees. There are some wallets that allow you to do that. There are some wallets that have dynamic fee management, so they kind of detect what fee they should add to prioritize it properly. So a block is considered formed when it reaches 1 megabyte in size, and that's usually about 2,000 transactions, as Dr. Steve mentioned. And in order to incentivize miners and to prevent rogue miners, miners are richly rewarded if they are first to solve a difficult math problem. If you made it really easy, then anybody could just submit a block and potentially, pollute the ledger. So you want to add some difficulty to it. And then in exchange for that, you reward them. That difficulty right now is just computing power. So miners must determine a hash of the block header that is smaller than a certain value, and this is a trial and error, where each trial is very time consuming. And miners validate the current block while receiving additional transactions for the next block. And then when somebody declares that they won, you may choose to validate that. Somebody usually does, or a bunch of nodes in the network do. Although many miners move immediately to the next block, assuming that whoever declared that they solved it has got it right. And then thus you create the chain. Now if you try to, we talked about this last time, if you try to come up with a block that nobody else is working on, you basically end up having an orphan block and nobody else builds on it, so you've wasted your time. Does that sound right, Dr. Steve?
That's a very good summary. Yes.
And if you're looking at the video version of this webcast, you'll be able to see these slides up there, including the lovely picture that I believe Shahin put together.
So really, the next question now is this whole notion of blockchain and Bitcoin, because everybody who gets introduced to this, at some point they ask, well, I like this blockchain thing, but Bitcoin I don't know about. Can I split the two from each other? And the answer seems to be no, and I think the answer seems to go to the root of what we're even doing here in terms of a cryptocurrency. So let's drill down into that question.
Yeah, I think the important thing here is really, you can have a centralized ledger as you have in the current monetary system. And just to remind people what money is, it's three things primarily. It's a store of value, it's a medium of exchange, and it's a unit of account. And the money, the fiat money that we're all familiar with, that we see as paper money or balances in our checking account, is all based on centralized ledgers. You have the ledger at your particular bank, and then you also have the really centralized ledger, which is the one at the Federal Reserve System that brings all of the bank ledgers together in some sense, and where the reserve balances are kept. Now, if we think about a distributed ledger, for it to work, it's got to be like open source. Everyone has to have visibility into it, and then you have an issue of how you keep security. We know how your banks keep security. We know how the Federal Reserve keeps security, but how are you going to have security enforced and honesty enforced and avoid counterfeit problem and double spending problem when you have a distributed ledger?
That all makes sense to me.
So then what you need to do is you need to have something like the process that we've just gone through, where you commit transactions in a way that the rest of the network can monitor it and can ensure that there's only one unique copy for the transaction. So Dan cannot send a Bitcoin to Shahin and then send the same Bitcoin to me and have that successfully make it through the mining process.
Right, because only one of those transactions will get approved and the other one will just fall by the wayside.
The other one will be pushed aside. So you need something like a proof process. This is proof of work. This is what the mining is. And the great insight that Satoshi Nakamoto had was to basically build an economy around this and to say you reward the miners as they commit things uniquely to the ledger. And so this is the money creation mechanism for cryptocurrency. This is how it comes into existence.
Yes. Yeah, this is, and it's a passive money creation. It all depends on the activity of the miners and the number of transactions in Bitcoins.
Mm-hmm. Mm-hmm.
Well, it's been called mining because it's kind of difficult to do. You have to expend a lot of energy, time, computer power, electricity, just as if you were mining gold or something else that had significant value. So Bitcoin, just like fiat currencies, is a store of value. It is a medium of exchange, and it is a unit of account. It does meet all of those things. Now, does it behave exactly like fiat currency? No. The store of value, we see that it's much more volatile. And in general, it's been increasing much more rapidly than the dollar bill in your wallet, but with a lot more volatility. But it certainly does act as a store of value along with a unit of account and a medium of exchange. It is not a medium of exchange at the level of a US dollar, though, because you can't just walk into your local grocery store and spend Bitcoin in most cases.
That's right. In terms of whether or not you can split blockchain from Bitcoin, the point seems to me that this whole blockchain model must keep track of a single unit of something. And that single unit of something has to be traceable, it has to be accounted for, it has to be completely transparent on what happened to it. So whatever you call that is also a common way to place value on objects of the transaction. So if I pay you 1 Bitcoin to get a whole bunch of pizzas, then the Bitcoin is tracked from me to you. The pizza really isn't. That's kind of between us to manage.
Yeah.
It is a common incentive for miners, and again, it's back to the traceability. So I think the point is that if you replace Bitcoin with something else, you've essentially redefined it. You've just replaced it with something else.
It's a new, like you say on the slide, it's a new currency.
It's just a new currency, that's right.
And you have to have a currency associated with this in order to give an incentive for any disinterested third party to participate in the vetting process.
That's right, that's right. Now, people who come in from why can't you split the two would say, well, I'll just pay dollars to incentivize people on the side. But then you really are redefining the whole process, and then you won't have this whole distributed consensus methodology that is in place with Bitcoin. So at the end, you need a single unit of something that is traceable, that is an incentive, that has a way of getting mapped to value. So whatever you call that is in fact the coin.
Well, that's the thing, is that even if you did give them dollars for this, you'd still be creating a token currency that, doing this much work equals that many tokens, which equals this many dollars.
That's right.
So in essence, you've created a currency again.
That's right. That's right.
It would be as if a country decided to fix their currency to the U.S. dollar, or in fact use U.S. dollars as exchange. Yeah.
Which happens.
Which happens.
Absolutely. And that's the thing, is I've been reading at least a bit lately about companies that are commercializing blockchain. Probably one of the most prominent is IBM, and talking about using it with clients to help secure the food chain.
That's right.
So
there again, the use case is traceability.
Yes.
Traceability is a common motivation to consider blockchain. And associated with that is digital rights management, right? Associated with that is a distributed way of consuming a product that you need to keep track of. So certainly if you want to know where a particular food package has been through its life, a blockchain seems to be a way of doing that.
But you still have to have something associated with that in order to give those miners, those what I call disinterested third parties, the incentive to do their computation on that chain and lock it in on those transactions.
That's right, Dan. And it could be a transaction fee. It could be a block reward. And there is also activity to look at other sorts of proofs, and proof of stake being the one after proof of work that's most talked about. But so far, pretty much everything, even Ethereum that wants to move to proof of stake, are currently working off of proof of work.
Yeah, I was going to say that anytime you've got a highly distributed situation to begin with, and food supply is definitely that, because you've got farmers and growers and grocery stores, and the whole food supply chain is extremely distributed. Then blockchain can be a path, because every node in that network is eligible to participate, and they have an incentive to participate because there is some reward that comes their way for helping keep the whole system coherent. Another place we've seen use cases for blockchain is in privacy and compliance. Again, because you need traceability and you need the guarantees of where something has been. Dr. Steve, you had a good example of a biomedical use case that was in that category.
Sure. I mean, there's a coin that's been issued, an initial coin offering called Gene Chain. So the idea is to track basically people's genetic information, and it would allow the patient to retain ownership of their DNA and yet share that with doctors and with laboratories and with research facilities as well. They could have the license access to it, and they might actually reward the owner of the DNA in that currency. So that's another example. Certainly Internet of Things is a very interesting one, and it then raises the question of scalability. So this is a big general issue for blockchain and cryptocurrencies, is how the scalability can be driven up by another order, 2 orders, and 3 orders of magnitude.
But kind of at the bottom of all of this is with the ledger and everything, you're establishing one version of the truth that everyone agrees to.
Correct, in a distributed way, without the need for a central authority.
And to me, one of the biggest real life examples, at least the one that has had my mind racing, is like the issuance of title insurance on a transaction of purchasing a home, for example, which is a reasonably complicated thing, but should be much simpler as more and more records become digital. But to me, that would be a very good application of blockchain technology.
Yes, there's actually there are multiple initial coin offerings around real estate, and to what extent they've driven down into the title process, I don't know, but it's certainly one that gets mentioned.
So I'm not going to make millions of dollars on this, Steve?
You could,
that idea?
if you have the best solution and move quickly.
I have no solution. I just have the idea.
Right.
I'd like to not be involved past that. But this is a very wide open, very interesting world that we're entering into. This whole idea of one version of the truth and being able to lock that down for all time is very powerful.
Without the need for a central authority.
Without the need for a central authority, that's the key.
So it seems to me that traceability plus a distributed situation plus scale are the ingredients that should cause you to think about blockchain as a path forward. Because if you don't need traceability, it doesn't matter. If it's not distributed, well, you can just keep track of it locally. And if it's distributed but it is not highly scalable, then it's not worth the trouble to go down this path. Which is really why, food distribution or data consumption, this whole notion of a data economy that is coming our way, Internet of Things, where you've got things scattered around of different shapes and sizes, those all seem like or indeed the financial, the fintech that we are observing, these all seem to have those ingredients in place.
Well, I guess we'll watch this area and see. I hope we've done a pretty good job over this past, hour and a half of podcast, maybe longer, to give you listeners and viewers a much better idea of what cryptocurrencies and blockchain actually are. Any closing thoughts?
Yeah, I think we are now ready to start covering what's really going on out there with blockchain, because all sorts of developments are happening, and we wanted to come back to them after we've done the basics, basically.
Yes. And plus, we've got other stuff we're working on, too.
True. It's not just about blockchain, yes.
Yeah, it's not just about blockchain. We're not just blockchaining animals here.
Also AI, also
yes.
Cybersecurity, yes.
So look forward to those topics in our next OrionX downloads, and thank you very much for listening.